Greetings. Today we'll do a schematic of a, variable power supply for 5 volts, uh, 11 volts, and 20 volts. So what we're gonna do first is establish what is a power supply. So it is a hardware component that uh, supplies power to an electrical device. It can be it can be it can take form as a battery or a hardware or anything. But it most its function is to convert AC supply into DC supply and vice versa. And other functions of it is to convert step down AC to step up AC and also vice versa. So the type that we're gonna do today is a variable power supply, which makes it easy to adjust the output voltage and sometimes the current itself. And yeah, so what we're gonna do first is make our power source. So with that, we're gonna have our voltage. We're gonna establish our voltage there. Then have our voltage dependent voltage source, which then we're gonna connect it parallel to our voltage source. There we go. So a dependent voltage source is provides a voltage supply whose magnitude depends on the voltage across. So yeah. Anyway, we're moving on to the next part, which is the full wave rectifier. What we're gonna do is arrange our diodes in a manner that's going to be that's going to make it a full wave. So for diode 1, we're gonna arrange it facing the left. As for diode 2, it's gonna face the opposite. As for diode 3, it's gonna be the same as diode 2, while diode 4 will be the same as diode 1. So yeah. So full wave rectifier rectifies a gives a full cycle of a half wave. I mean a sine wave. That means it has the positive half cycle and the negative half cycle together, creating it. So what we're gonna do is go make the part that you know so there's our Zener diode. This next part we're making are for the different voltages that we're gonna achieve today, that we're supposed to get for this. Oh wait, it's this way. Go resistor parallel to the diode. Oh wait, no, in series with the diode. There you go. And there's our capacitor. Gonna put our first capacitor here. Oh, wait. Here I'm gonna connect that. Go back down. I'm gonna. So this is for our second one. The second one we're gonna do. Basically, it's gonna be like the first one we're gonna do. Like the first one we did. So that's where we'll put our Zener diode. Nope. Okay. Here. Then put it in series with the resistor. Then just go up, completing it now. So next one, it's gonna go from here. There we go. Yep. Connect these. This is where our capacitor will be. This is where our capacitor, third capacitor, will be. Connecting it to the other two. Then go down, put our resistor here. Then go there. There you go. So that's gonna be the fourth one. I mean the third voltage that we're gonna get as an output. There you go. Delete these X's. Now I'm gonna put the ground there. The next thing we're gonna do is to label the parts. So that's gonna be 0, Based on my computations, it's going to be 311.126.9837 with 60 hertz as its frequency. For this one, its value is gonna be 0.094581 without the E. Now this diode would become 1N and 4001. It's gonna be the diode that we're gonna use for our full wave rectifier. So right now, I added these. Yep. And as for our capacitors, they're all gonna have the same value. So that's gonna be 2,200 nanometers. Just got to have to the new symbol. And as for the resistance, we're gonna have all these resistors are gonna have the same resistance, so that's gonna be 320, 320, and then over 320. Now, what's gonna differ is our Zener diodes, since they're gonna emit different ranges of voltage. So for this one, we're gonna use a D1N75 For this one, we're gonna have D1965, 62A. For this one, we're gonna have a diode D1 964 68A. Oh wait, yeah. Now with all that set, transmission time of D. Oh no. 100, 500 M. Gonna put that here. Gonna put my name first. So, oh wait. Gonna put my name. Also, Engo. And this is a wrong one. this is refined variable power system. So let's label the appropriate parts. This is V in, and this is V out 1. That's our second one. This one's our third one. The last thing before I do, the last thing I need to do before I run this is to correct this. These are supposed to enclose the capacitors. So, yep, there we go. Now, let's see. Oh, yeah, let's do those. So for V out 1, there's 5. The steady supply of 5 voltage, and steady supply of 11 voltages, and steady supply of 20 voltage. So traditionally for power supplies, they usually do the two inductor thing to form a transformer, and supposed to be either a step up or a step down. So here I computed for a value of the voltage source as well as the dependent voltage source, so that it can be filtered here, and each one of these kind of like cells can process the specific voltage source. And I used Zener diodes, a specific Zener diode, so that it could process these voltages, so that it will the desired voltages, the 20, 11, and the 5 voltage would come out of this circuit. So would come out here. So yeah, that's basically it. So again, this is the circuit, and I hope you enjoy and learn something here.